This comes out of section 8.3, logarithmic functions. The inverse of that, if we take you back to some Math 30 for a second, x equals b to the y is going to be the reflection of those graphs about the line y equals x. So what that'll look like is this asymptote that was at the x-axis now becomes the y-axis, and I have either a graph that looks like this, or in this case a graph that looks something like this. Instead of writing this as x equals b to the y, often what we write is log base b of x equals y. And that is our log function, and we've run into those a bunch of different places, a bunch of different times. In general, if we look at our domain, x needs to be greater than 0. You can't log 0 or negative numbers. And our y is an element of the reals, can be anything. If we look at some limits, if we said what's the limit as x approaches 0 from the right of log base b of x, it depends in this case which one we're talking about. More often than not, our base is greater than 1. So in that case, as I approach 0 from the right, this graph approaches negative infinity. If I was to do the other way, and say what happens if x gets really large, the limit as x approaches infinity of log base b of x, as you log a larger and larger number, you get a larger and larger number, and so that one would approach infinity. And as you can see by the graph, its end behavior is that it does point up. If we start by doing a quick little sketch example, if I sketch a specific one here, y equals 10 to the x. Again, exponential growth, but this time I can actually label some points and say, okay, it goes through 0, 1, 1, 10. So there we have a graph. Now if I was asked to draw y equals log base 10 of x, that is exactly the inverse function of the one I just drew. So we have ourselves a function that looks like this. It goes through 1, 0, and 10, 1. Instead of having the x-axis as an asymptote, it has the y-axis as an asymptote. Now if they were to ask us to do something like y equals log base 10 of x minus 5, I would just take that graph that I just drew and move it 5 units to the right. 1, 2, 3, 4, 5. My asymptote is now there, and each of these points that I had labeled is now 5 units further over, so 6, 0, and this one will be 15, 1. That in itself isn't a particularly important graph, but it's useful in questions like if I were asked what's the limit as x approaches 5 from the right of log base 10 of x minus 5. If I know what that graph looks like, I can look at this and go, oh well, as I put in 5.0001, 5.000001, I'm logging a progressively smaller, tiny number, and that gives me an answer that heads towards negative infinity, which is the reason why we have that vertical asymptote there at x equals 5.